Okay, so this is finish up this walkthrough for this assignment. So now we're looking at volume. So I looked up this equation. I have no idea what the actual volume is of this complex 20-sided shape. So I just looked it up. Again, depending on what you chose, there are other shapes are easier. But here we go. It's 5 multiplied by 3 plus the square root of 5 divided by 12, and then multiplied by a cubed. So a is the length of one of these edges for these equilateral triangle faces. So we saw that A was 1 centimeter for our person, and for B, A was, I think it was 2.5 centimeters, and for our last one, A was 4 centimeters. So we're just going to take our calculator and find out the individual volumes. So I have 3 plus the square root of 5. Get a number, so that number comes out to be 5.236, 0.67, etc. We're going to multiply that by 5 based on the equation. I'm going to divide that by 12. So that's this complex thing right here comes out to be 2.1816949, etc., etc. So now we're just going to multiply that by a cubed. So in this case, a is 1, so multiply by 1 cubed. So we get a volume of 2.18 centimeters cubed. Again, to visualize what that means, 1 centimeter cube, picture a little box, that's 1 centimeter on a side. So that is 1 centimeter cube. 2 centimeter cubes would be 2 of those. So 2.18 would probably like something like that. That is how much volume we're talking about. So for shape B though, we're going to repeat this equation. This 5 times 3 plus root 5, that's 2.18. We're going to multiply that by 2.5 to the power of 3, based on the equation. So we find out our volume here is equal to 34.1 centimeters cubed. Again, to kind of picture that, 34 boxes, like so, would fit inside this next shape that we have. And for our last one, it's 139. So 100 and let's just round it to 140. Okay. So again, there's multiple ways we can find our k cube factor. So what this tells us, this tells you how much our volume is going to increase by if we have a scale model based on that k value originally found. So our first one, we found out that the k factor was 2.5. Right? Our first k factor was 2.5. So it doesn't mean we're going to have 2.5 times more volume. We have to actually cube that value. So we say, okay, k cubed, if we do 2.5 to the power of 3, it tells us that the next shape, this other object, is going to have about 15.6 times greater volume than our original smallest object. If I compare A to C, you say, okay, what's k cubed? Our original k was 4. Do that 4 divided by 1. 4 to the power of 3 is 64. So k cubed here is 64. And from B to C, our k value is 4 divided by 2.5, so 1.6. If I cube that value, we get k cubed is equal to 4.096, or 4.1. Okay, we have those values. Again, the other way we can solve those ones if we actually look at our volumes and divide. So if I take this 34.1 and divide it by 2.18, so 34.1 divided by 2.18, again, you can follow along with your own calculator, you get a value of 15.6. So great. So kind of a way of double checking. Take that 140 and divide by 2.18. Again, I should get 64 here. Yeah, 64.22. Again, it's not going to be exact because we're rounding. Take 140 divided by 34.1, 4.1. Pretty much matches bang on. That's pretty much it for the math side. Do some volume calculations and really try to make this connection between k, k squared, and k cubed. K is our length scale factor. K squared is our area scale factor. And k cubed is our volume scale factor. So if we keep going down and just go over the last steps, it's saying what's the cost of each shape. Usually when people are making things, it's like this is kind of determines like how much. Like this is like if you're doing cost benefit analysis of something, you're gonna make something bigger or smaller. I think Starbucks, for example, they'll often keep making their cups smaller and smaller and smaller. But there's ways to decrease the area of the cup, but still try to maximize the volume, for example. Okay, so shape A, well, I'm not gonna do the exact ones, but let's say we had a area of 10 centimeters squared, right? If we just multiply that by this ratio, this $2 per centimeter squared, we'll see the areas cancel out. We end up with $20. Just trying to we're just trying to put in perspective how much more, like say, if you were to say make a larger version of something or make a scale model of something, how much more would it actually cost? Again, experiment volume measurements. We're trying to actually see, like, hopefully we'll actually see by if you're say to pour sand or flour or water, if you make a good material, we should hopefully see those exact same K cube values in there, right? So when you actually fill up the first object, we should see that whatever our K value was, I can't remember what it was, but the first K value was 2.5. So if we go again, 2.5 to the power 3 was 15.6. Okay, we're hoping that we physically fill the second object up with volume compared to the first object. You'll actually see 15 times more stuff go into the second one. That's what we're hoping to see. And that's when to do actual like comparisons, we do need to make sure our units are similar. I do have another video up on how to do unit conversions, because most likely when you do this, your measuring tool will probably be in milliliters or liters, or if your measuring tools are imperial, they might have some different type of, it might be in ounces or things. You can very easily just plug these values into Google, do the conversion for you, but it's basically for us to accurately compare, we need to actually make sure the units match up. So you convert from whatever you're using to centimeters cubed, so we can see that comparison. And for the very last step is a comparison of results. Yeah, so explaining. And clearly I did a typo for this one. Summary activity. This will be like summarize your activity or summary of like what you've done. So it's basically summarize your findings. So it's show in a sentence or two or three that you understand what it is or what the whole point of this assignment was. So I hope that helped, and I hope that sets you on your way to completing this assignment with whatever shape or 3D shape you chose to go with.